Start recording. I'm glad that I'm doing only homework. Okay. Arten get like did you okay? You can't see my page, Wissam?
Yes, sir. Now
Now it can.
yeah, I can see it. Yeah, the same.
So
It's the same answer.
okay, this it's okay then. This is okay. What we did.
Yeah,
This
it's
is
very clear.
using the property, right? Using the property. Many students they don't like uh, uh, the property. They want the shortcut method, and I don't like it. But what can I say? If I ask them a question like this, they do it in a different way. What they do is you gave me you gave me a condition, right? Given that what is it? Uh, cos alpha is 3/5, and it is in the first quadrant. It is on the first quadrant. I can find it with a calculator. Then alpha is second function cos, right? Of 3/5. Second function cos of 3 divided by 5, and I got 53.1 degrees, right? So then he gave me also the fact that, what did he give me? Cos beta, the negative 12 over 13. And you know that cos beta is here. Beta is here. So a reference beta, beta reference would be then cos inverse of, ignore the negative. So second function cos of 12 divided by 13, you get 22.6 degrees. That's a reference angle. Then the actual beta is this one, right? So you can take 180 minus that reference angle, or that reference angle. 180 minus your reference angle, which is 180 minus 22.6 must be 157.4. Thank you. 157.4 degrees. Now, what they did, you asked me to find tangent of beta minus alpha. So I'm going to go, what is tangent of beta minus alpha? And I got the numbers. So tangent of 157.4 minus 22.6. We should get the same answer, except for a little, because of these approximations, we're going to be a little bit deviated. But so minus 22.6, and then you take tangent. I got, well, I don't know, negative, is it really? Yeah. What did I mess up? Or maybe my numbers are not right. 157.4 minus 22.6, tangent of that.
I think it's 53.1 instead of 22.6.
Oh, something's not right. Okay, so what is this? Oh, I probably hit tangent. 12 divided by 13, second function cos. Did he give me cos?
We are using reference beta and beta. We have to use alpha instead of 22.6. Yeah, alpha 53.1. We are using beta reference with beta standard here.
Okay, I want to find what I
22.6. Yeah.
Oh, yeah.
22.6.
Yeah.
It's 53.1.
Okay. No, 53.1 is, yes. Here, you mean? Yes. In here, 53.1. Yeah. Everything is okay, except that one. Sorry. So tangent of the difference. You're right. Alpha is 53.1 instead of 22.6. 22.6 only helped me to find me beta. That's it. It's done. So what is 157.4 minus 53.1, and take a tangent? It is negative tangent of this is negative 3.9232, and what did we get? Negative 63 over 16. Negative 63 divided by 16 is negative 3.9375. Oh, there is a lot of approximation, yeah? Do you understand what I'm trying to do, Wissam, though? I'm trying to explain.
Yes, yes. Yeah.
Yeah.
I got.
With the numbers, regardless of the numbers I'm getting, the method works both ways. So many students really try to do this because they want to depend on the calculator, but actually the book is giving you this question for you to use the identities or this kind of relationship. So I prefer this. Any other question? Okay. All right. So no other questions. Then we continue with the where we stopped. Okay. So I'm going to do more examples of section 20.2, which is sum and difference formulas. So in this So I just want you to recognize, I want you to recognize number 12, for example. The question is to simplify. Number 12. In the book, I have sine 3x cos x minus cos 3x sine x. Do you recognize this?
Yes.
What is it? Go ahead.
Sine 3x plus x minus x.
3x minus x. Excellent. This is sine alpha cos beta minus cos beta, no, cos of alpha. I don't like this sine of beta. I prefer to switch the angles, not the functions. So that's exactly what that is. So this is nothing but sine of 2x. See, you can subtract this, and then you can write the answer. See how this complicated form is exactly equal to this. You know, that's the reason we learned this identities. Can you change them in the format you like when you're doing advanced math like integration or differential equations? Can you be able to write this as such? So instead of integrating this, you're going to integrate this, which is so much easier. That is the significant role of the trig identities in integral calculus, particularly integral calculus. So I teach a lot of integration classes, and sometimes I have students who didn't do this chapter when they did differential equations, when they did differential calculus. The course we're doing, because this is pre-calculus, we focus too much onto the derivative. So this is no derivative. It doesn't have any calculus topic, but this is fundamental. And then when I do integration, the problem is my students could not follow me because of these identities, lack of this knowledge. For example, I say integral of cosine to the 4x minus sine to the 4x dx. This is hard integration. Forget about this. I'm not teaching integration. But the bottom line is the algebra. The algebra is important. Now, any calculus concept is easy. The algebra part is the hard part. It's not even algebra. It's like a pre-calculus algebra, which is what we call fundamentals of algebra. So you would do, okay, let's integrate cos to the squared x minus sine squared x, because it differences two squares. Let's integrate cos squared x plus sine squared x. This is difference of two squares. This is equal to 1 by section 1. This is equal to cos 2x by section 2. So this integration becomes cos of 2x dx. I do it this way, but if you don't know these identities, how you come to this point? Okay, and then you can easily integrate this. The integration is not part of this topic. I'm not going to discuss that. But the simplification process, the breaking down and identifying if there exists an identity or not, is the skills of a math student that has to have. So I really emphasize, if you're doing, I'm sure you're going to do MTH 404. These are very important. Okay, these are not the questions though. So just recognizing this is what I'm trying to emphasize. Next question is number 14. Do you recognize this identity? Tan of x minus 1 plus tan x. Check the formula and look at it, and then if it satisfies what is in the formula set. I think it does. This is simply tan of alpha plus tan of beta, 1 minus tan of alpha, tan of beta, where alpha is x minus 1, when beta is x. So you can treat this as tan of what? Tan of what? Alpha minus beta or beta, alpha plus beta is my question.
Plus.
Plus, very good. C12 plus, thank you. Tan of alpha plus beta. So alpha is x minus 1 plus beta is x. Because we said if the tangent of alpha plus beta here, this is plus. If tangent of alpha minus beta, this is minus, we said. And also, we got to be careful about this. If this was plus, you wouldn't do this question at all. You wouldn't say it so, because it's not in the right format. So technically, this is simplified too. You can do the addition subtraction inside. It is actually 2x minus y. So this bulk is actually this one. Okay. Next question I want to do is number 60.
Sir, at the bottom, it's tan x at the bottom. Tan x minus y, tan x.
Oh, the question, yes. You're right. Thank you so much, Lisa. 16, cos of 2 pi minus x. Could you expand this for me? What is cos of 2 pi minus x? How do we expand it? Do you remember the rule?
It's cos, sine, sine.
Excellent, Wissam. If it's minus, what is it?
Plus.
Excellent. Thank you. Cos 2 pi cos x plus sine 2 pi sine x, period. So cos of 2 pi is 1, you know, you can use calculator, but I tell you this, I use unit circle. I never use the basic functions. I never use my calculator. The unit circle, always the x and y are, this is cosine theta, this is sine theta, because normally they are r cos theta, r sine theta, but r is 1. That's why I'm calling it unit circle. Unit circle means a circle with radius 1. So here is 1, the point is 1, 0. Here is 1, the point is 0, 1. Here is 1, the point is negative 1, 0. Here is 1, the point is 0 and negative 1. Okay, so what is theta here? Theta is equal to 0 degrees. So sine of theta, as I told you, is y. Cos of theta is equal to x all the time, because it is y over r or x over r, but r's are 1 in this case. The radius are 1 in this case. So in my case, if I say sine of 0, what is it? Sine of 0, take the y value of that, which is 0. Sine of 0 is 0. Cos of 0 is 1. Cos of 0 degrees is 1, because it takes the x coordinate. It's 1. Okay, so 2 pi means the whole circle again here. 2 pi is right here. So cos of 2 pi is 1. The cosine takes the x value. Cos x plus sine 2 pi is still here at this point. Okay, we are still here because 2 pi means the whole circle back to that point. So sine of 2 pi is the y value, which is 0, times sine x. So technically this is cos x. You know, you can use calculator though. Okay. Number 18, quickly, we can expand sine of x plus pi by 2, right? We know the expansion as sine of the first angle, cos of the second, plus sine of the second, cos of the first. That's what I like. I don't want to switch the functions. I switch the angles. Sine cos of pi by 2, right here, right? At pi by 2, this is 90 degrees. What are the coordinates? Cos is the x value, so it is 0, times sine x plus, what is sine pi by 2? Sine pi by 2 is y, which is 1 times cos x, which is equal to cos x, really. Number 20, I have cos of x plus pi, cos of x minus pi, plus sine of x plus pi, sine of x minus pi. Right? Do you recognize this? What kind of formula is that? Is there a pattern that you can connect it with the formula sets that we've discussed? Definitely, think of it.
Isn't it cos is equal to alpha minus beta?
Thank you, exactly. Cos, cos, sine, sine. It must be cos of, because this is plus, then it must be minus. So the first angle is x plus pi, the second angle is x minus pi. Thank you so much. Cos of x minus x is 0, pi minus minus pi is 2 pi. And of course, cos of 2 pi, as you remember, 2 pi is here because the whole circle back 2 pi. This is 1, 0. 1 is for cos of 2 pi. 0 is for cos of 2 pi, right? So this is actually 1. The whole thing is equal to 1. Cos of 2 pi. If you don't like what I'm doing in the unit circle, you can use your calculator. Cos of 360. is 1. So I'm going to do section, well, that's good enough for the section 2. I'm going to do section 20.3. Double angle formulas. The double angle formulas are formed from the sum and difference. It's very easy. Once you understand one, every one of the trig identities can be derived from the previous formulas. So what is double angle formula? So the relationship, first of all, I want you to understand what we have here, the compact form, and the, say, for example, if we have sine of 2 theta, you will have something of theta here. So these are called double angle. Somehow, they are not equal. They would be sine or cos, whatever. Okay? So if you have tangent of 2 alpha, for example, you will have alpha here somewhere. That's why we call them double angle formulas. Okay. How do we come up with? We know from section 20.2 that, what do we know? Sine of alpha plus beta is sine of alpha cos of beta plus sine of beta cos of alpha. So what if, my question is, what if alpha is equal to beta? Does it give me sine of 2 beta or 2 alpha? Yes, on the left-hand side, this implies sine of alpha plus alpha equal to sine of alpha cos of alpha plus sine of alpha cos of alpha. On the left-hand side, I get sine of 2 alpha. On the right-hand side, I have twice of sine of alpha cos of alpha. So this, here you have it as a no identity, you know, which is called double angle formula. So this is known as the sign of double angle. Sine of 2 alpha is 2 sine alpha cos alpha. From now on, what is example? You can write sine of 10x as 2 sine of 5x cos of 5x. You can write that because relate these angles. This is half of this, or this is twice as much as this, and also the pattern goes the same. The definition goes the same. With sine 10x is 2 sine 5x cos 5x. Even sine of x, you can write it. What is half of x? It's x over 2. 2 sine of x over 2 cos of x over 2. See, as soon as you see 2 sine of x over 2 cos x over 2, you should change it into sine x because it satisfies this definition. What is twice of x over 2? It's x. So that's why we have those. All right. Now, that is one example, one formula. The second formula is, can we do the cosine? You know, cosine of, we also know from previous section that what? Cosine of alpha plus alpha, what is the cosine formula? Cos alpha minus sine alpha, right? So I didn't know what I was giving as an example was relevant now. It is cos squared alpha minus sine squared alpha. So this is cos of 2 alpha. All right, this is a new formula. cosine of 2 alpha has many formats. This is a number 2 formula, but it could be changed. What do you know about cosine of alpha, cosine squared alpha? Who can tell me? In section 1, we did what cosine squared alpha is.
1 minus sine squared.
Yes, thank you. It is 1 minus sine squared. So I can replace that to get another formula, 1 minus sine squared. Why? Because sine squared x plus alpha, cos squared alpha is an identity. So cos squared alpha is 1 minus sine squared alpha. You know, we did this already in section 1. Okay, so I'm going to replace cos squared by 1 minus sine squared of alpha, minus sine squared was there already, and then I have 1 minus twice sine squared of alpha is cos 2 alpha. So this is the first one formula. Second formula for cosine. Cosine of 2 alpha has 3 formats, and but you can also change. This is when cosine squared alpha is 1 minus squared of alpha, but you can also change sine squared of alpha as 1 minus cos squared alpha in the original function here. Therefore, this implies cos of 2 alpha equal to cos squared, keep it, change sine squared, 1 minus cos squared of alpha in brackets. So this is cos squared of alpha minus plus cos squared of alpha minus 1, which is twice cos squared of alpha minus 1. That is another formula for the cosine to alpha. So cosine to alpha has 3 versions. You will use them as you wish, as you like them, as the way you want them to be used, right? So, but the most popular one is this, the top one. I mean, the number 1. Why is it number 2? Oh yeah, number 2 because the double angle formulas for sine was done. Cosine is the second one, and the third one is a tangent. What is the double angle formula for the tangent? We know already from section 2, we know that tangent of alpha plus beta is tangent of alpha plus tangent of beta over 1 minus tangent of alpha times tangent of beta. This is a property, but if alpha and beta are equal, so this becomes 2 alpha, tangent of 2 alpha, right? Tan of 2 alpha is change everything to alpha, tan alpha plus tan alpha over 1 minus tan alpha, tan alpha. So this becomes 2 tan alpha over 1 minus tan squared of alpha is tan 2 alpha. That is the double angle formula. Is called the double angle formula. Double angle formula for tangent. Oh, this is a double angle formula for. This is a double angle formula. Of course, for cosine. And the double angle formula is this one for sine. It is actually recognition. The main thing I'm asking is, do you recognize it? When they give you like this, could you condense it into this? When they give you this one, could you factor it like that? That is it. Or, I mean, math, all about that. Recognition. Do you recognize it? Do you associate it with the problem you're working with? It is the most important part of mathematics, to recognize and apply to your problem. You know. All right. So this section is devoted to those 3 functions, those 3 formulas. Okay. I'm going to do examples. So the book, the questions are found. I will altogether, I will post the homework on content week 8 folder. So on 20.3 double angle formula, page 561, section 20.3 on your textbook of page 561. Most of the questions are prove or show or simplify. So for the first one, I want to do number 6. Find 120 by using the functions of 60. Number 6 is find sine of 120 degrees by using the function of 60. The function of 60 degrees. I know the relationship is 60 is half of 120. So we know that sine of 120 means sine of 2 times 60. You don't have to write this all. You can go directly to sine of 60 degrees, cos of 60 degrees. You can skip that. Because you know that this will match as sine of 2 alpha is 2 sine of alpha cos of alpha. That's what we said. So they don't even want their number, the number of sine 120. If they want sine of 120, they could just plug 120 in the calculator and find it out. What they want is a relationship between sine 120 and then sine 60 product of sine 60 cos 60 and times 2. Number 8, find cos 60, or I think maybe find. Find means what? 2 times sine 60 is root 3 over 2 times cos 60 is 1/2. You could do it this way, I guess, because they say find. I didn't realize. So root 3 over 2 is, I think, by calculator, it's 0.866, I guess. What is sine of 120? Yeah. Okay. The second, find cos 60 using 30, obviously, by using 30. Okay. We know cos 60 is what? Who can tell me the factorization or the identity using 30 degrees?
1 minus 2 sine squared and then 30.
60. Yeah, I'm glad you brought this up. 1 minus sine squared 60. Because cos squared, well, it's not even squared. So, but it's not square. So we can't use this. We can't use this at all. This is not even square. Only the squares are comparable in that sense. But if it was a square, this is right, not 30. The time when we use 30 is when we use double angle formula. The double angle formula for cosine of 2 alpha is, oh, could you say that? Did you say 2? Could you say that again?
Yeah, I said 1
you
minus
mentioned
2 sine. Yeah.
Oh, yeah, you're right. Yeah. So 1 minus 2 sine of squared of 30 degrees. Perfect. Because one of the formulas I gave you for cosine is this. He used this one. That's true. This is 2 alpha and then alpha. Perfect. Sorry about that. Okay. I thought you said 1 minus sine squared alpha, which is not right. So, or it would have been 1 minus, no, 2 times cos squared of 30 minus 1. Or we would have what? Cos squared of 30 minus sine squared of 30. These are both all all answers should be the same. So 2 cos squared alpha minus 1, cos squared alpha minus sine squared alpha. Okay, so of course you can always do that. Cos of 30 is root 3 over 2 squared minus sine 30 is 1/2 squared, which is 3 over 4 minus 1 over 4, which is 2 over 4, which is equal to 1/2. Of course, cos 60 is 1/2, isn't it? And you don't have to follow mine. You can use calculator. By calculator, you're going to get 1/2 right there. But I think you need only one answer. I use this one. That's the popular one. Okay? But the main issue is to really understand the relationship between the identities. So most of them are like that. So I'm going to go to the simplified version. These are just finding numbers. So the simplified one on question number 20. What is simplify number 20? Can you simplify 4 sine squared, 4 sine squared x, cos squared x? Yes, I can, right? Because I realize that can I write 2 sine x cos x as a base and then change it as a squared? Because 2 squared is 4, sine squared is sine squared, cos squared. So I could have changed this as, because I want to use the 2 sine alpha cos beta, cos alpha. So 2 sine x cos x, the whole squared. And then I can change this. This is equal to sine of 2x, the whole squared, really. 2 sine x cos x is sine 2x. Or sometimes calculus textbooks, they avoid writing the brackets, so this is how they write it. So first, change it into a base, and then the base is recognizable because it satisfies the double angle formula for sine. Next question is number 22. We will be on break at 9. 4 tangent of 4 theta over 1 minus tan squared of 4 theta. Do you recognize this? The only problem is the 4. I could have recognized it, but the 4, there is no 4 in the formula. What is tangent of 2 alpha? It is 2 tan of alpha over 1 minus tan squared of alpha. Do you look, they're similar except for the 4. So I'm going to do, this is 2 into 2 tangent of 4 theta over 1 minus tangent of squared of 4 theta. So your angle alpha is 4 theta. When you change it to the compact one, it becomes 8 theta. It will be doubled. 2 tangent of 8 theta would be the answer. This, remember, you cannot just change it. Some changes has to be done on the angle before you change it to the compact form. When you're going from the expanded to the compact form, make sure you double the angle. When you're going from the compact form to the expanded form, make sure you half the angle. That is a question. Number 24. Two sine of half x, or x over 2, cos of x over 2. This is very obvious. It doesn't matter. This is sine of alpha, cos of alpha. This is a typical double angle formula of the sine. Double angle formula of the sine. No matter how complicated the angle is. It's not complicated. So my alpha is x over 2. So I'm gonna what? Double the angle, right, on the left. So who can tell me what is it? 2 sine x over 2 cos x over 2 is equal to what? Yeah. It's nothing. Direct Arthur. It's sine 2x. Really? If you had x in the expanded form, you would have sine to double the angle, right? What do you have as an angle there, Arthur? The angle that you see is x over 2. Why don't you double that one? Yes, it's a sine x. Good job. So this is sine x. Because double of x over 2 is x. Okay, number 26. Cos 3x sine 3x. Cos 3x sine 3x, almost double angle for the sine. So I will work here on the side. We know that 2 sine theta cos theta is cos of 2 theta, we said. No, sine of 2 theta, we said. So if they give us only this, you got to divide by 2, right? So this implies sine theta cos theta is sine of 2 theta, because 2 is missing on here, divide by 2. So I will just do, this is like cos theta sine theta. So I'm going to have to double sine of twice of 3x, which is 6x, but divide by 2, because the 2 is not here. So that is the answer. So number 28, cos to the 4u minus sine to the 4u. This is a little bit difficult, but you do factorization. For this one, you do x to the 4 minus y to the 4. What do you do? In difference to squares, x squared squared, y squared squared. Make them difference to squares, and then you'll have a product of 2, one with the plus, one with the minus. All right? That is algebra I did in 128. So here I got cos squared u, cut the exponent by half, and then squared, the same as cos to the 4, minus sine squared u to the 2. So the difference between, see, the difference of squares. The difference of squares is factored as the base plus the second base times the first base minus the second base. So, but this is a property. What is it? What is cos squared of u plus sine squared of u? It's 1, Arthur. You're right. What is cos squared of u minus sine squared of u?
Cosine 2u.
Excellent. Yes. It is exactly the definition of double angle formula for the cosine. The definition, see? Cosine squared of u minus sine squared of u is cosine of 2u. Right? Perfect. So what I have is, here is 1 equal to 1. Here another identity here is cosine of 2u. So the answer is cosine of 2u. Okay, the last question I want to do before I go on break, so I can come back and do the new section. is cosine of, oh, simplify again. All of these are simplified. Yeah. Number 30, simplify cosine of 3x over sine x plus sine of 3x over cos x. The problem I have is I cannot even add them because the denominators are different. So the lowest common denominator, which we call LCD, must be sine x cos x. To do so, I have to adjust the top and bottom. I'm missing cos here, so multiply cos to the top. And then I'm missing sine here. I multiply sine to the top and to the bottom. But that way, I make them the same denominator. And then I can, if A over B plus C over B, I can do A plus C over B. So this is cos to the 3x cos x plus sine to the 3x sine x over sine x cos x, right? So what is the top though? What is this? Can you tell me? It's section 2. The trig functions of addition and subtraction. Like, yeah, it's Sivan. It is cos of alpha minus beta. You're right. So the top is cos of alpha minus beta, which is 3x minus x over sine of x cos of x, which is equal to what? Cos of 2x over, what is this anyway? Might as well change it into 2x angle. So I might have another relationship with the top one to make it more compact. What is sine x cos x? We did it here. Here. Sine x cos x is sine 2x over 2. Sine x cos x is sine of x, sine of 2x over 2, because the 2 is missing here. So sine of 2x divided by 2, which the 2 goes up and gives me cos of 2x over sine of 2x, which is twice of cotangent of 2x. So we will stop here. I will see you in 11:12 after break. Thank you so much for your attention and participation. I appreciate it. Break time for 10 minutes, okay? For me, it is a very lengthy day. I have 6 hours of class. I should tell them I can't handle this kind of schedule. I'm an old guy, yeah. But anyway, yeah, next time I'll tell them. Break time, and I'll stop recording.